All right, so we are continuing with solution of 2022 Physics 105 exam questions for students in the Faculty of Science. Question 6A here says, AI says define Pascal's principle. Pascal's principle states that the intensity of pressure for a fluid at rest is equal in all directions. That's Pascal's principle. Next one says Archimedes' principle. Archimedes' principle states that if um, when a body is partially or totally immersed in a fluid, that it experiences an upthrust which is equal to the weight of fluid displaced. Next one says coefficient of surface tension. The coefficient of surface tension is simply the ratio of the force or the surface tension force to the length of a material. So coefficient of surface tension is simply equal to force over length. That's it. Ratio of force per unit length of a fluid. That's all right. 6b says discuss the following pressure in static fluids. What pressure? Pressure is simply the force acting per unit area of a fluid. So pressure in static fluid can be defined as the force acting per unit area of a static fluid. So that's how we define pressure in static fluid. The next question here says define viscosity. The term viscosity is similar to friction, but viscosity is simply the friction that occurs in fluid. So by definition, viscosity is simply the friction that occurs within the internal layers of a fluid in motion. So that's how you define viscosity. All right, it is the friction that occurs within the internal layers of a fluid in motion. The next question here says define cohesion and adhesion. The principle of cohesion and adhesion helps substances to stick together. Cohesion is simply the force that allows particles of the same substance to stick together. Example, the force that allows the molecules of water to stick together is called the cohesive force, while the phenomenon is called cohesion. For adhesion, or perhaps adhesive force, is simply a force or a phenomenon where different substances can stick together. Example: if you pour water into a glass cup or something, even when you pour out the water from the glass cup, you still observe that there are little droplets of water still on the glass cup there. Now that phenomenon is due to adhesion. So adhesion, we said, is a force that allows substances of different particles to stick together. So the force that allows the water molecule to stick to the glass is called the adhesive force, and that phenomenon is called adhesion. So that's what you have for cohesion and adhesion in liquids. All right, cohesion is a force that allows liquids of similar particles to stick together. Example: water molecules. Adhesion is a force that allows particles of different substances to stick together. Example: water sticking to glass. So that's what you have. All right, let's look at the B part. The B part says, what is the area of the smallest block of ice, 0.50 cm thick, that will just support a man of mass 100 kilogram, assuming the specific density of ice is 0.917 gram per cm cube, and the ice is floating in fresh water. So let's get this done, please. Our first task would be to list out parameters. So now we are now in the B part. List out parameters given. So given, they said number one, thickness of block, thickness of ice, or it's the ice block, whichever one. Let's call this what? Call it T. Okay, T, the thickness T is equal to 0.50 cm. Number two, they said mass of the man, given the mass of the man, and the mass, let's call it M. The mass of the man, M, is equal to 100 kilogram. And next thing they said, assuming the specific density of ice. Number 3, specific gravity or relative density, same thing, is equal to 0.917 gram per cm cube. They said the ice is floating in fresh water. Okay, so we have to find what there. What's the area of the smallest block of ice? So IV, area of ice, is what we have to find. Area of ice block. So A is equal to unknown. All right. So how do we get? So those are our given parameters. I think that's all. All right. How do we get the area of ice block? What do we do? All right. So the first thing you observe that is wrong with this question is that we're given specific density or specific gravity, and we're having a unit, which is wrong. Specific gravity is a dimensionless quantity. That means it has no unit. So that means this one shouldn't be there. It's an error. All right, so we'll take this one off. All right, so specific gravity has no SI unit, so you take it off. Alternatively, perhaps the meant density. So if it actually meant density, then it should be gram per cm cube. So you do your appropriate conversion. But for here, since it's specific gravity, we are taking off the unit because it has no SI unit. Our first task here would be to find the density of the ice block. Let's get density of ice block. What do we know? We know that relative density, also called specific gravity, is equal to density of ice all over density of water, which is 1000. So we said for us to get density of ice is equal to specific gravity of ice times 1000. So we can say recall the formula that density of ice is equal to specific gravity of ice times 1000. That's density of water. That's equal to density of ice is equal to specific gravity 0.917 times 1000. If I multiply this, that gives me 917 in kilogram per meter cube. So I have density of ice as being this. So this is the density of ice. Okay, so what next? Let's get the volume of ice. Volume of ice. I know that volume is equal to, or volume is measured in meter cube. Meter cube is something as saying meter squared times meters. And whenever I talk about meter squared, what comes to mind is area. So volume is equal to area times meters, which in this case will work with the thickness of block. So that's T. So using area of the ice times thickness of the ice block will give you its volume. So our task will be to convert this in here. Okay, so that will be called volume of ice. V of ice is equal to area of the ice, which we'll have to find. We called it A. So area of ice. Should we put ice there? Okay, so just to be all right. So area of ice. So area of ice times the thickness. So this thickness is in centimeters. Let's convert to meters by dividing by 1000. So the volume of ice is equal to area of ice multiplying the thickness of ice. Divide this by 100 becomes 0.5 all over 100 to convert it to meters. So I have this. So hence the volume of ice will be equal to, if I do this, I'll be having this as 0.005 area of ice. From here, 1 to 0.5. All right, so this is the volume of the ice. All right, so having gotten this, our next task, to solve this question, we need to use the concept of Archimedes' principle. For Archimedes' principle, it says when a body is partially or totally immersed in a fluid, that it will experience an upthrust equal to the weight of fluid displaced. Look at the question there. Question said, what is the area of the smallest block of ice that will just support a man of mass 500 kilogram, 100 kilograms? So the man here, you have a man lying or perhaps standing on ice here, and then you have water here. So once this man stands here, this ice will go down a bit, and hence this water here will exert an upthrust on the man here. The upthrust exerted by this water on the ice is equal to the weight of this fluid displaced. So we say from Archimedes' principle, we say upthrust is equal to total weight displaced Now, why we're using total weight displaced because the total weight is equal to the weight of the man plus the weight of the ice block. All right, upthrust, as we know it, is equal to density. Of course, the upthrust rho All right, so upthrust is equal to rho of the upthrust is being exerted by the water body on the ice. So rho of water times volume of ice times gravity. So upthrust, please note that upthrust is equal to rho Vg. We've already derived this in our previous class. I'll leave the link to the class on density and relative density in the description of this video. All right, so I explained why this is so. Right, upthrust is equal to density of water, volume of ice, and then gravity. So that means the upthrust, let's call this U. U is equal to density of water is 1000 times volume of ice is 0.005 area of ice times gravity is 9.81. Let's see if you are given a value for gravity. Any value to use here? From the question, we're not told the one to use. Okay, from the initial question, we should use 9.8. Right, so I'm using 9.8. So get this, it means that upthrust U is equal to, if I multiply everything here, that gives you 1000. Let's see my calculator, 1000 times 0.005 times 9.8. Confirming by value, that's 49. So 49 times the area of ice. I've gotten the value for the upthrust. Let's get total weight. The total weight displaced is equal to total weight is equal to mass of the man. So mass of the man times gravity. That gives you the weight of this man plus, for the weight of the ice block, what to get the weight of the ice block. All right. So we know weight is equal to rho Vg, same thing as upthrust. Of course, both of them are still in Newton. So the weight of the ice block, that's weight. This is total weight displaced equal to So total weight displaced is equal to weight of man plus weight of ice. That's equal to weight of the man is equal to mass of the man times gravity plus weight of ice. We can get weight by saying rho times V times G. That becomes density of ice times volume of ice times gravity. So see the difference. When I'm getting upthrust, it becomes density of the liquid, which was water, 1000 fresh water, but for weight, right? While we're using the same formula, rho Vg, the difference is that for upthrust, the rho here is the density of the liquid, which was fresh water or water, 1000. While for weight, the same formula, but density here is density of the solid, which is the ice, times volume of the ice times gravity. So that's like the difference between the upthrust rho Vg and the weight rho Vg. I'll take that one more time. The difference between weight rho Vg and upthrust rho Vg is that weight rho Vg, that's density. For weight, the density there becomes density of the ice or the solid times volume of the ice or the solid times gravity. While if I'm considering upthrust, for upthrust is equal to density not of the solid but of the liquid immersed, which was water. We use 1000. All right, times volume of ice times gravity. That's like difference. All right. If I impute values, this is equal to total weight displaced is equal to mass of the man, 100 in kilogram, 100 times 9.8. That's mass times gravity plus density of ice. Do we have that value? Yep, 917. So 917 times volume of ice. Yep, 0.05, 0.05, 0.005, 0.005 area of ice times gravity 9.8. All right, so this is 2 in one bracket. All right, the last one there, question 6C. Still on question 6. The C part. Question says a gold bracelet weighs 7.8 Newton. However, when immersed in H2O, that's water, it weighs 6.86 Newton. Find the upthrust and the density of the gold bracelet. All right, solution. My first task there will be to list out given parameters. So what am I given there? The first thing that I'm given is the weight of gold bracelet, perhaps in air. So weight in air, I'll call that W air. We said W air, the weight in air is about 7.84 Newton. Number 2, it says, however, when immersed in water, so number 2 is the weight in water. Weight in water. Let's call this WH2O, as they said. That's equal to 6.86 Newton. All right, they said find the upthrust and the density of the gold bracelet. What's upthrust? Upthrust is also called a loss in weight. All right, when solids are immersed in liquid, they will lose weight. So hence upthrust. So let's call the first one there. Let's call the A part upthrust, also called loss in weight. Loss in weight, they're the same thing. So upthrust is equal to, so it weighed this amount in air and this amount in water. It has lost some weight. How do you get the value of weight lost? Very simple. Upcharge is equal to the weight of the gold bracelet in air minus the weight of the gold bracelet in water. And that's equal to the weight in air is 7.84 in Newton minus weight in water is 6.86 Newton. So therefore the upcharge U is equal to 7.84 minus 6.86. That's about 0.98. Upcharge is measured in Newton. So that's simply the loss in weight. I have 0.98 Newton as the value. The final question there, B, says find density of gold bracelet. B, density of gold bracelets. How do you get density? Density is equal to mass over volume from the weight. Please, you're using the weight in air because the weight in air is the original weight. We can get the mass from there. We know that weight, mass, is equal to weight over gravity. So if I divide this value, the weight in air, by gravity, I'll have the mass. Let's now get the volume. The volume of let's recall that weight is equal to mass times gravity. To get mass, divide here by gravity, divide here by gravity. Therefore, mass of the gold bracelet is equal to weight of the gold bracelet. Please, in air, which is equal to 7.84 all over gravity is 9.8. So the mass in air, or the mass of the gold bracelet, is equal to 7.84 divided by 9.8. That's about 0.8 kilogram. That's the mass of the gold bracelet. Let's get volume of gold bracelet. So for volume of gold bracelets, how do we get that? Recall that we said upcharge is equal to density of fluid, volume of solid, and then gravity. So we can say that the upcharge is equal to volume of the liquid. In this case, the liquid was water. Density is equal to density of the liquid, which is in this case is water. So I'm using density of water times volume. Volume in this case, volume of the solid, which is the gold bracelet. So I'm saying volume of gold, that's gold bracelet, times gravity. All right, let's get this done. So it means that the upcharge 0.98 is equal to density of water is 1000 in kilogram per meter cube times volume of the gold bracelet times gravity 9.8. To get this value here, I'll divide here by 1000 times 9.8, divide here by 1000 times 9.8. This cancels this, this cancels this, this cancels this. So the volume of gold is equal to 0.98 all over. If I multiply this, 9.8 times 1000 times 1000, that's 9,800. So the volume of gold is 0.98 all over 9,800. That's about 0.0001 meter cube. All right, that's the volume. That's the value for the volume of gold, 0.0001 meter cube. So therefore, the density of the gold bracelet is equal to the mass of the gold all over volume of the gold. That's equal to the mass of the gold, which was this one we got here, mass 0.8 all over density of all of our volume of gold, 0.1231. All right, so this one here was in kilogram. This one here is in meter cube. So if I do this, it means that the density of the gold, which I'm asked to find, is equal to 0.8 all over, 0.8 all over 0.1231. That's 8,000 kilogram per meter cube. So this becomes the density of the gold as required in the question. All right, so this is how we solve this question. All right, so that's all for 2022 Physics 105 solution for Faculty of Science students. See you in our next class.